Everyone. We're still waiting for a few people to join this session. I am Andreas Wuller, Associate Professor at the Australian Industrial Transformation Institute, or AITI for short, at Flinders University. If you were expecting our director, Professor John Spear, to open this session, I'm afraid he had to send his apologies. Before we start, I just want to note that this session is being recorded. My colleagues and I would like to recognize that Flinders University operates on Indigenous peoples' traditional lands and waters, and that we acknowledge their continued responsibility to care for country at the university's various locations, which includes the land of the Kaurna people from where I am talking today. I would like to welcome you to the newly constituted AITI seminar series on the future of work in the digital age. Today's is one of 5 fortnightly presentations set up to run over the next 3 months. Today we are pleased to host Dr. Navinda Kottege from CSIRO Data 61, who will be giving us an overview of the state of advanced robotics in Australia. But before I hand over to Navinda, I'd like to say a few words about AITI and our seminar series. AITI is located on the Tonsley Innovation District in South Australia. It's actually on the site of the former Mitsubishi manufacturing plant, which closed down in 2004. Since then, this site's been transformed into a place where trade, tertiary, private and public sector organizations come together to facilitate innovation through shared connections and sharing of knowledge. So we not only have Flinders University here, we have TAFE here, we have EAA Systems Maritime Australia here, and we have a number of small and medium-sized businesses often working together on the same location. Also on this side is Flinders University's pilot factory of the future, where we work with a range of partners to promote modern manufacturing through research and training. With our seminar series, we want to link the work of practitioners, academic researchers, and policymakers. So we've put together a series of talks that cover a range of topics which are all connected and all relate to the future of work. So today we'll be hearing about robotics. In a fortnight's time, we will be hosting Professor Hugh Bradlow, who will talk to us about the promise or otherwise of digitalization and automation. So we're covering topics of the prospect of technology and also the challenges of employment. Later talks will address questions of future demand and need for training and skills. We will have a talk about the global political economy and macroeconomics of future of work. And sometimes overlooked, we have a talk about the social consequences and opportunities that arise from how we may work, and importantly, how we may assign work in society in the future. You can see details on our website, but we'll also be sending them out to those who registered for today's presentation. But today, the topic of the day is automation. Is automation inevitable? So we are pleased to begin by exploring the state of the art of robotics and its application and the barriers to application in Australia with Dr. Navinda Kottege. Now, Navinda is the group leader and a principal research scientist at CSIRO's Data 61 Robotics and Autonomous Systems Group. He has done and led robot research within CSIRO since 2011, and importantly is the principal investigator and project leader of the Data 61 team that successfully competed in the US DARPA Subterranean Challenge. Now, DARPA is the US's Defense Advanced Research Project Agency. It's basically the R&D arm of the US Department of Defense. The challenge, the Subterranean Challenge, was for competing teams that came from across the globe to send robots to unknown underground environments and perform a number of set tasks. And that was in September last year, and Navinda and his team tied for the top place, the top spot. And after a tiebreaker, was placed second in this global challenge overall. No mean achievement. If you haven't done so already and haven't seen it already, I'll encourage you to look up the event video on the CSIRO website. Just Google it, or maybe just Google Navinda. So Navinda will speak for 20 to 30 minutes. During this time, if you have any questions, please use the Q&A function, which you should see at the bottom of the screen. It's the two chat bubbles. And use that to share your questions. We will collect and read them out at the end of Navinda's talk in our Q&A session. When asking questions, if you wish to introduce yourself or your organization, please do so. And on that note, I'll hand over to Navinda.
Thank you, Andres. Bear with me for a second until I share my screen. Can everyone see my screen? Perfect. All right. Thanks again, Andres, and thanks to AITI for inviting me. I'm very excited to be here today and talk to you about a really relevant and exciting topic. And yeah, as the title suggests, I'll try to answer the question: is automation inevitable? Automation has many flavors, and then given my background, I will approach automation from a robotics and AI point of view. So this is the outline of what I intend to talk about today. In the process of answering the main title question, I'll pose a few more additional high-level questions and then also try to define a few concepts. So I will start here by briefly introducing my organization, CSIRO, for those who are not familiar. So the Commonwealth Scientific and Industrial Research Organization is Australia's premier government-funded research organization with a history of a bit over 100 years. We employ over 5,000 staff members organized into 9 business units spread across 58 sites, mainly across Australia, but we also have a few overseas locations in Singapore, Vietnam, Chile, and the US. CSIRO's research areas are quite broad and spans agriculture and food, land and water, health and biosecurity, oceans and atmosphere, space and astronomy, minerals, energy, and data science. So as part of Data 61, the business unit responsible for data science research, I lead the Robotics and Autonomous Systems group consisting of around 50 staff members and around 40 students and affiliates, a total of around 90 people. And this site here in Brisbane is where I'm based at. So going back to the outline. So let's start by asking the question, what is automation? As I mentioned in the beginning, automation comes in many flavors, and therefore it has a number of definitions that go into specifics. In general, automation is the use of technology to reduce human intervention in a process. And as mentioned again before, I will be talking about automation from a robotics and AI perspective. What that means is it makes sense to ask the question, what is a robot? So human ingenuity had shown a knack for automation of tasks for many, many centuries. Robots are a natural progression of this trend. So modern day robots go beyond the automation of repetitive tasks that were commonly assigned to robots, such as working on a factory assembly line. So robots are machines that conform to what we call the sense, think, act paradigm. So sensory inputs from cameras, LiDARs, radars, inertial measurement units, motor encoders, etc. They're processed and used by the robot to understand the environment around it and its own state as well. So this information is then used to make inferences and make decisions, and that is what this think box represents. And these inferences are, and decisions are then passed on as control commands to actuators and control systems to act upon the environment. Any changes in the state of the environment or the robot's own state would then be observed by the sensory system, and then the loop continues. The design and the programming of the robot would then determine the type of sensing, the nature of the decision-making process, and then the actions that are performed. This paradigm would apply equally to a small Roomba-type vacuum cleaning robot as well as to a 4,000-ton automated drag line used in open cut mining. So here are some robots used in various domains for various tasks. Some of these may not even look like your typical robot that you're used to seeing. So I have included a few robots that we work with in our lab here as well. So those who can identify them might win a prize. No, just kidding. I haven't actually discussed that with the organizers, so I don't think that's going to happen. But anyway, moving on. So the branch of robotics that we focus on here at CSIRO is called field robotics. And this is where robots are deployed into environments where we have little or no control of the environmental variables, such as complexity, structure, obstacles, lighting, air quality, traversability, so on and so forth. So why do we work in this area of robotics? What are the challenges? So this is one of the grand challenges that I identified. So to read it out, it's to create smart, reliable, mobile machines capable of performing more capably than equivalent crude machines in a wide variety of unstructured environments. So in the context of this grand challenge, what are the problems we are trying to solve through robotics research? So here are a few high-level problems. Trying to solve challenges in mobility, in autonomy, and safety. And these can then be further decomposed into research areas. For example, each of these smaller circles would encompass a myriad of unanswered research questions that would then lead to PhD topics, master's topics, and so on and so forth. So what do we have next? What can robots do? So trying to answer this question, what can robots do? So what we postulate is they can perform dull, dirty, dangerous, and devilishly impossible jobs. Until recently, I only had the 3Ds, but a very learned colleague of mine from NASA pointed out that there's a fourth D, which is the devilishly impossible jobs. So let's look at these in a little bit more detail. So there are many instances in various industries and scenarios where humans have to put themselves in harm's way, either to perform a routine task or to respond to an emergency. Industrial examples include humans having to enter extremely confined spaces, such as the wing cavity of an aircraft, and inspect sewerage pipes, or working at extreme heights, such as in power line inspection and building construction. Other examples come from emergency response and safety inspection, where humans have to enter potentially hazardous environments. Think of aftermaths of an industrial accident, underground mines with hazardous gases, or nuclear power plants such as Chernobyl with high levels of radiation. These types of jobs are typically classed as dull, dirty, or dangerous, or the 3D jobs, and would benefit from introduction of robots who can remove humans from harm's way. And there's another class of activities that require robots to achieve either scale or efficiency, examples being large-scale farming or large-scale environmental monitoring. So here I have some pictures of robots designed to monitor the Great Barrier Reef, And there's another robot deployed to assist in bushfire fighting. And then, of course, a farming robot here. So what can robots do to benefit us as humans? So taking the previous example of confined space inspection, with the advent of autonomous robots capable of going into these spaces, the human expert can still make the relevant decisions based on data streams coming from the robot without having to physically enter these confined spaces themselves. And as a consequence of that, they have a much better quality of life while still using their specialist knowledge. And this is already happening in a number of sectors. So here there's a picture of a human entering hazardous confined space. That's kind of the state of the art in many domains, where you have to be wearing these protective suits. But then in the bottom here, you have an autonomous drone being deployed into a confined space. And on the right, you see the human experts looking at the data streams coming from this autonomous drone to be able to do the inspection from the safety of a comfortable office. Similarly, mine workers and emergency responders can rely on robots that enter dangerous environments to give them crucial information about the presence of toxic gases and other hazards before entering these environments to perform tasks. On the left, mine workers are deploying a drone with 3D mapping capability to get situational awareness in an unsafe part of an underground mine without having to enter those areas themselves. On the right, you see the detailed 3D maps created by these robots. And this, again, is already happening. And here's another example where humans are inspecting a sewer system. Definitely not a pleasant environment to work in. And on the right is a state-of-the-art legged robot deployed on an inspection task in a tunnel. I'm sure you would agree that it is better to send a robot for these inspection tasks than to send humans. While it is still not widely adopted, these technologies are maturing and slowly starting to be used in real-world applications. Beyond the above examples, tasks such as efficient high-yield farming to address the future global food supply needs would require robotics and autonomous systems due to simply the sheer scale and complexity of requirements. Additionally, to perform environmental monitoring and ecosystem management, which will increase in priority with the adverse effects of climate change, will also require robots and autonomous systems. Examples are monitoring the Great Barrier Reef, for example, which is over 1,000 kilometers in length, and biodiversity monitoring in rainforests. Use of robots will give us unprecedented ability to collect data at very large spatial and temporal scales. Here's a specific example, the Great Barrier Reef. Crown of thorns starfish, they're destroying the reef as they feed on the hard coral. And whenever there's an outbreak, human divers are sent to do the surveys, and they have to manually inject a vinegar-like substance to kill them off. As you can imagine, this is not a scalable solution whatsoever, given the sheer vastness of the reef. And this is an application that will definitely benefit from robotics and autonomous systems. On the right is a prototype autonomous underwater vehicle that had been developed to detect and eliminate crown of thorns starfish to protect the reef. These are not still widely adopted, but these technologies are being developed and matured. All right, so where are we? Is automation inevitable? So this is the big title question that was posed at the beginning. You may have come to your own conclusions based on what was presented up to now, but this is what I have as an answer. So my answer is yes. However, it's not a simple yes. The rate of absorption in various sectors would be different. It is worth understanding why this is the case. And it is related to the broader topic of this seminar series, which is future of work in the digital age. So future of work. Now, future of work is changing, whether we like it or not. And there are anxieties in society about robots taking away our jobs or killer robots. Similar to what happened with the Industrial Revolution, with the advancement of robotics and AI, the way we work is changing. This will continue with the improvements made in hardware, software, and AI techniques going into the future. As with any technological development, negative effects will be inevitable. However, we strongly believe that the potential benefits far outweigh the drawbacks. In reality, completely new industrial sectors will be created as a result of adoption of robotics. This is already evident by looking at various job titles we encounter now compared to, say, a few decades ago. And similarly, this trend will continue where some industry sectors would eventually diminish in significance and other new areas would emerge. This would ideally allow humans to move towards roles that require creative thinking and specialist knowledge. And these graphs give us some interesting insights about what's happening globally and what the trends are. In the following slides, I will show you a bit more detail or in the context of some scenarios as to how this is panning out. So if you look at the top graph that shows the annual installation of industrial robots, the 15 largest markets. So you can kind of see who the big players are here. And then the compound annual growth rate in robotics and the various types of robots that are being used. All right, so next one, future of work and automation. So let us continue to dissect the answer to automation. Is automation inevitable? So in my view, automation is a function of demand, which is what is needed, and technology, what is possible. So I'll try to explain this in two scenarios. So the first one, take mining in remote parts of Australia, for example. So workers are flown in and out to perform tasks. There are plenty of dangerous jobs in these operations. And there comes a point when it becomes morally unacceptable for organizations to put humans in harm's way when there is technology available to do those tasks. And on the top right inset, it's a large mining truck used in the Pilbara region. And there already are fleets of autonomous trucks in operation in mines in Australia. And this has been the case for more than a decade. So there are certain parts of industries or certain industry sectors, and even within those industry sectors, there are certain jobs that are already being automated. And there are some dull jobs as well, not just dangerous ones. And an anecdote is we heard from one of the industry clients that we were talking to that they actually have to send fly-in, fly-out workers, I think it was twice a week, to check whether rubbish bins were full in the staff quarters in these remote mines. So that definitely is not a job that a human would enjoy doing. So I'm pretty sure that that sort of jobs would benefit from a level of automation using robotics and AI. Let's go to scenario 2. Now, the second scenario I present has a lot of relevance given that we are in the middle of a pandemic. And scientists have known for a long time that zoonotic viruses, the ones that can transfer from non-human animals to humans, have the potential to cause pandemics. Therefore, there had been a lot of effort globally to catalog these zoonotic viruses. From what I understand, around 1,000 such viruses have been cataloged so far. However, experts estimate that there are over 500,000 uncatalogued zoonotic viruses out there. The vectors for these viruses are typically small mammals such as bats and rodents. So how is this cataloging done? Humans in hazmat suits like what's shown here goes into rainforests and remote caves to collect samples of animal droppings or dead animals. This is neither scalable nor safe. And this is an activity that would definitely benefit humanity if it can be automated with robotics and AI. Unlike the previous scenario, there really where there already are applications in automation. In this scenario, we are not there yet. We still don't have robotics and AI technology that is advanced enough to conduct these tasks. All right, so what can we do? So how should we approach this? The most important part is to understand what is already happening and plan accordingly. Try to identify completely new areas of industry creation and what the needs are that are currently impossible to service. And it is also important to understand the robotics and AI value chain, understand where we can fit in and to contribute and to influence. So I mentioned the robotics value chain. So it is critical to understand what this is. And this is in fact a global value chain as well. In fact, this particular diagram, I think it's missing a critical component of the value chain and has some significance to Australia, and I will get to that in a bit. So this is another very interesting statistic mentioned in the recently released Australian Robotics Roadmap. So this kind of gives us an indication of where things are heading. So the use of industrial robots seems to be slightly slowing down, but service robots seems to be really going up in numbers. And there's another one that people in manufacturing will be quite familiar with. So this is called the smiling curve. So what we're missing in the earlier value chain diagram was R&D. As you can see from here, there's a massive value addition at the R&D stage. Then from the previous slide showing the trend in increase in service robots, it can be viewed in the context of how service provision with robots can again have a massive value addition. Both R&D in robotics and providing robotics and AI-based services can be seen as great opportunities for Australia. We are already punching above our weight in robotics-related R&D, but this is an area that we have a lot of growth potential. So to effectively face the future, we will have to see changes in all of these and more. And I was very glad to hear the upcoming topics when Andreas was introducing the seminar series, and I think most of these will be covered in the upcoming seminars. So I believe most of us present today has the potential to be the ones to influence and enact some of these changes. So skills and education, they're linked. Education institutes are already starting to offer courses in micro-credentials in key areas of robotics and AI. A very startling fact, a startling statistic that I saw recently was out of all the board members in companies and organizations in Australia, less than 3% have had STEM-related education qualifications. So therefore, education is linked to mindset, which then feeds into regulation and policy. So to recap, so automation is inevitable, in my view, and it is coming, whether we like it or not. However, whether we see it as an approaching storm or instead a favorable wind to fill our sails is up to us to decide. I believe there's a saying that says we cannot direct the wind, but we can adjust the sails. So with that, I thank you for listening. So thank you very much. I'll be happy to answer questions.
Yes, thank you. Brilliant talk. Enjoyed that. Have a few questions myself, but there are some questions coming in. So let me just check what we have. Right. We have a question. I'm just going to read it out to you. Dr. Kottege, you acknowledge that there are many aspects of robotics that are necessary to achieve an aggregate like autonomous vehicle. If they may eventuate, I'm not convinced, in brackets, how skeptical should, I presume, we be of current timelines? So this is a question about, how speedy are we going to see change happening?
Thanks. It's a good question, but it's also a hard question to answer because timelines are tricky. So you have to be very skeptical when certain very ambitious timelines are mentioned in the media, and by various parties, because the answer to that, at least the answer that I have, is it really depends on which sector, which area, under which circumstance. So if you look at autonomous vehicles, I think that's what motivated the question. Right now, the technology is fairly mature for us to have autonomous vehicles in, let's say, highways, where things are quite well controlled. However, if you put one of those cars in a country like India, where you have very chaotic traffic conditions, that would fail miserably. So we need to be cognizant of what the marketing hype is and what's actually possible. So I wouldn't say that I'm skeptical, but I guess being a bit more realistic about what the technology can achieve and the attached timelines. I don't know whether I properly answered the question, but
well, can I add on to that and ask you, from the work that you're doing, whether you have any kind of insight into which sectors or which areas are driving automation change at this point in time, and the opposite, there may be laggards as well. Is there a trend visible?
I think that there are certain areas where, say, traditional industry sectors, let's say mining, they're really seeing the need to embrace these technologies, because for as I mentioned earlier, when technology is available where you can remove humans from harm, so it becomes morally responsible for an organization to still keep using humans. So there's that aspect to it. And then there are certain things that were simply not possible before, and now possible because of automation. So that is another driver for that. But at the same time, there are some traditional manufacturing domains. The aerospace industry, for example, it's sometimes a contradiction in itself, because we have the most advanced airplanes that are being developed, but if you look at the process in which they're being manufactured, they're still, in most cases, still being developed how they were developed 50 years ago. So there are opportunities there to really embrace what's possible with the current technology and the technology that will be developed in the future to enhance those industries. And then there's a whole other area where like environmental monitoring at scale, monitoring the Great Barrier Reef. They were not possible before because we just didn't have the technology that could scale. But technology is emerging now where we can apply that. So similarly, as I think there'll be industries that you and I can't even imagine right now in another decade's time. So I think that's the beauty of it. So it's rather than kind of be too worried about what's going to happen to the current industry sectors, it's keeping an open mind that there will be completely new industry sectors that would flourish in the coming decades.
Mm-hmm, mm-hmm. Great. We've got a couple of questions coming in concerned about the future of work and the impact that automation might have on employment. So the first one here from Loki is, how are we preparing society, in brackets, people, system, politics, and economics, so it's the whole range, to adapt to the changes automation will make, so we transition without mass unemployment, and the massive process of adapting to the changes. And Loki adds on to that, what role do you think engineers can or should play in educating senior decision makers about possibilities, risks, and options?
I think the answer to the question was part of the question as well. So education, absolutely, and mindset. I think that's an important one, and I do acknowledge that this type of change will affect different parts of the world in different ways, and different demographics in different ways as well. So I think in one of my slides, I had a statistic from one of the reports that developing countries, there's potential for mass unemployment in the coming decades. So that is a reality that we will have to face. But again, I think in my view, education and upskilling is the answer, where kind of have that mindset that there will be other industry sectors that open up. So it won't be the traditional ones that we were familiar when we were growing up. So through education, through upskilling and influencing policymakers, I think we can still have a positive outcome.
Again, I'd like to follow up on that one. Your answer seems to imply that the upskilling is the answer. So we need more skills, presumably because the more unskilled tasks will be taken over by the robots. So that those people who may be conducting these today would have to find other employment opportunities. Could it also be that at the higher skill level, we're seeing some displacement by robots, for instance?
It's an interesting one. So this is not specifically robots, but if you take high skilled professions such as medical professionals, something that we might not realize already is that there are certain decision-making processes or decision support systems that are already being automated. When you get a medical diagnosis, let's say from your MRI or something like that, you might not realize it's the human doctor that might actually convey the message to you, but the decision might have been made by a automated or AI system already. So there is that already happening, and sometimes people are not even cognizant of that or aware that is actually happening. So to me, in a way, that's not such a bad thing. So it's not seen as a sector being taken away, but I'm almost seeing humans and machines working side by side to a certain extent, or humans and AI systems collaborating to come up with better outcomes for the benefit of humanity.
We've got another question on the risk of or to employment. And it's asked, how do you foresee the transition between automation being inevitable and automation being ubiquitous? So I guess that this is about the early stages of automation, and when does automation become automatic?
It's an interesting question. So I don't think I'll have a definitive or authoritative answer to that. I can speculate. I can give some opinions. So I don't think that there'll be this kind of sudden change where everyone wakes up one day and realize that everything's automated. I think that's not going to happen. It will be a gradual change, and even within sectors, things would happen gradually. So as I mentioned earlier, like in the medical profession, we're already seeing that. We're already seeing certain parts of it being automated, and I do understand that the transition period would not. As with any change, transition periods are difficult. But I try to kind of look back at what happened during the Industrial Revolution centuries ago, and I'm sure it will have some parallels to that sort of thing. And certain areas would adopt technology much quicker. Some would be lagging behind, but eventually, things will all progress in a positive direction.
We've got another question, which it's not so much about the history and the transition, but it's a sort of the geography and a question of economic development. Judith Chan asked, deployment of an automated solution in a production environment is still a hard task. As an automation engineer in an Asian country, our labor-oriented workforce needs to be upskilled to use automated solutions. So we see automation inevitable, but so far away. Any thoughts on that?
Good question. So recently we came across a company. It's a startup based in the US. They have an interesting paradigm, which is I think trying to address exactly this sort of thing. So if you take a factory where you have workers, you have work cells, like you have certain workstations doing tasks. So if you think of automating the whole factory, it's a pretty daunting task. Like it's massive capital investment and massive disruption. But this particular company, they have a very interesting view on this. So they go in and talk to the owners of the factory who are running it and try to understand what their pain points are. Like what's from a worker point of view, like what's the dullest job, like what's the most repetitive job, or where are the bottlenecks. And they actually bring in robotic work cells that pretty much take exactly the same footprint as a human worker, and then they try to install that. So that's their business model. So one example that they showed was in a factory. This was in the US. There was this lady whose job on 8-hour shifts was to position hand sanitizer bottles on a little tray, so that a little print head would come and print company logos on the hand sanitizer bottles. So her job continuously for 8-hour shifts was to pick this hand sanitizer bottle from a box, place it on a tray. So to me, I'm pretty sure that we can do better as humans to kind of do more creative things where we really use our human ingenuity. So what they are doing is they're trying to come up with a robotic cell, not automating the whole factory, but they can kind of take the human out of that situation. So that could be an interesting approach to kind of gradually automating these sort of scenarios, rather than go in and say that the whole factory needs to be automated.
Yeah. There's a follow-up question, a relevant one here from Amber, asking automation nation can't be inevitable or maybe inevitable for every nation in the world. How would you predict the readiness of nations from developing countries?
That again, I would go back. I know it probably sounds repetitive, but I think it'll again go back to mindset and education. And honestly, I believe that some developing countries have massive opportunities, even compared to some currently developed countries, if they can properly exploit their strengths in that value chain of robotics. So you look at the robotics value chain. Yes, there are these really advanced, high-end robots being used, let's say in the military or in various other places, but they need to be built. They need components. They need programming. So where does that come from? I think that's why it's really important to understand the value chain and find your strengths as a nation, as a community, and then really exploit that. And that's why I think it's super important to kind of get the mindset right and have education, changes in education to address that.
I do wonder whether developing nations is the right word to use in this context, because we have, take India, sometimes still referred to as a developing country, but one of the leading tech nations at the same time. So it's not just a question of the general state of development in a country, but there are pockets of brilliance and excellence everywhere that I suggest may just have to be utilized.
I fully agree, and I think India is probably a brilliant example of a country exploiting this value chain and understanding where they can really make an impact. And as you rightfully said, they are leading the world in certain areas of technology, supplying into this value chain and creating a lot of benefit through that.
Yeah. I've got a question here that refers to your presentation, Navinda, and it says on the slide outlining the different aspects of research into robotics, can you please elaborate on some of them, in particular physical interaction with workers? I'm not sure whether we need clarification which slide exactly that is. Do you know which one's been referred to?
I think I had a number of kind of sub areas and subtopics, so I might have had physical interaction. So that is an interesting area that we ourselves are getting into. So if you in traditional robotics, if you think of navigating for a mobile robot or for a robot manipulator, collision avoidance was a big thing. So you would try almost at all costs to avoid colliding with things or unintentionally interacting with things. But for you to do useful things, you have to interact with the environment. You have to, I guess, make control collisions, so to speak. So that is an interesting area. And if you look at pictures that you can find on factories with robots, you don't see humans in those factories. These robots are usually in these caged cells because it's way too dangerous for a human to be even close to these robots. But this paradigm is changing. So this whole concept of cobotics, or having humans and robots share the same space, is becoming a thing. And there's a lot of technology pull, and then there's a lot of R&D going into that. So this is to have work cells in a factory where you can have a shared space where humans and a robot can share that space. So there has to be a lot of research there needs to be a lot of R&D that has to go in to make this work. So if you take again manufacturing, let's say in an aircraft manufacturing facility, and they're manufacturing a section of a wing or whatever. So there are many different tasks that you have to do on that. So riveting, polishing, properly connecting the fasteners and all of that. And what the industry is heading towards is to have a mixed environment where a robot might be good at doing a particular task, a human would be far better at doing another type of task. And rather than just doing one thing and moving the whole workpiece to another location for the other person to do it, it would be far more efficient if you can do it in the same space. So that's where this kind of physical interaction of robots and humans come into play. So that's a very active research area.
Great. Right, application commercialization. A question here. From the outside, it looks like Australia and the CSIRO are punching above their weight in automation research, but it seems there might be a bottleneck, and I think one of your graphs referred to that, a bottleneck in application and commercialization of research. Does that ring true? And what are some of the barriers in Australia, do you think?
That unfortunately is a reality. I think things are getting better in Australia, and it's an area that we can definitely do better. And I think this is probably true for the university sector, but also in CSIRO, we generate a lot more IP than what ever gets to see the light of day. So this had been recognized as a challenge, and then CSIRO had put in a lot of mechanisms in place to address this, where commercialization gets a lot of internal support, where we are really trying to be driven by impact to transfer the technology out of the organization into the hands of practitioners. And we've got some really great examples of that recently. But I think the missing piece, especially in the robotics and AI domain, is to have that ecosystem of many players. So that's something that you have in countries like the US, if you take the Silicon Valley, or in parts of Europe. And I think Australia is slowly getting there, but it's not there yet. So it's not just a matter of spinning out a company or setting up a joint venture. I think you really need to have that ecosystem of multiple companies where even talent can move across from. And I think that's a that's a good direction to head in. And I think we are getting there. And then there's some, I guess, policy and regulation changes, funding bodies, and again, if you look at the amount of, I guess, venture capital funding available for commercializing technology in Australia and the US, there's still a big disparity there, and hopefully we can fix these things as we go on.
Can I follow up with another question of my own here? I wonder whether cost of automation and the application of automation is an issue. The examples you've given, mining companies, these are wealthy organizations working at a huge scale, have tremendous capitalization, cost, outgoings, but also income. Overall, Australia is more sort of a small, medium-sized economy. Some argue it's a small-sized economy. To what extent does automation research favor the big spenders, the larger businesses, or put differently, to what extent is automation perhaps not entirely affordable for other than the biggest players in the game?
That is an interesting question, but I would see it slightly differently. I can speak on behalf of what we do at CSIRO. We tend to be motivated by the problems rather than who comes with the problem. So, and as you may know, CSIRO is a not-for-profit agency, so we are not necessarily driven by kind of by the profit, because we don't make a profit out of it. So we are motivated by really difficult challenges. And more often than not, what we're finding out is that some of these really hard challenges, if we solve them, that has broad-ranging applicability. I wouldn't say that there's a single thing that we've done in the recent past that will only work in the mining sector, or only work in the defense sector, or anything like that. So we are really driven by solving difficult challenges that would have applicability in a very broad range. And I believe that paradigm would try to, at least to a certain extent, mitigate, I guess, this disparity between the big companies and then the small companies.
Yeah. Continuing briefly with the theme of practical barriers, there's a question that's come in. Avishka, looking for business advice, for someone who wants to create a startup in the field of robotics. What would you suggest are the biggest challenges?
Look, I'm probably not the best person to give that advice. I see myself as a roboticist, not necessarily an expert in giving business advice, but I think what I can offer is to really study the market, like really understand what the pain points are in current practices, and also try to, it's hard, but try to predict the future, like what would be the pain points for an industry sector in another decade's time, type of thing. And talk to people, talk to as many people as possible, talk to practitioners, talk to people who are actually doing the work on the ground. And even for us as researchers, that's always eye-opening, and we really enjoy doing that, rather than being confined to our labs or desks and computers, trying to kind of do our little bit of research. Whenever we go out to a factory, whenever we go out to a manufacturing plant or a work site, it's a really rewarding learning experience for us, because in your mind, you might be looking at things from a technology-driven point of view, but when you actually go and talk to the practitioners on the field, that's when you will start seeing things from a more application point of view rather than a technology point of view. And I think that's where the magic happens. That's where you can really identify how technology can then kind of help the practitioners on the field to achieve better outcomes.
Right. I'm conscious of time, but there are two questions that I'd like to hear the answers to myself. One is, with the increase in the use of automation and AI, how do you see the government regulatory framework to support safe operations of these evolving into the future?
I don't think I'm fully qualified to answer that question because I'm
it's a difficult one. Yes.
It's a difficult one, and I'm not necessarily an expert in that area. I think it's again a dialogue where everyone gets educated, where from a technology point of view, researchers and technology experts get more familiar with the constraints and limitations that regulatory authorities have to deal with, and also regulatory authorities and governments understanding what's actually possible with the technology at hand. So I believe the solution would be based on a dialogue where each party gets informed by each.
Right, cool. But just got two more questions, and they are kind of related. One is, where do you see opportunities for non-traditional and or STEM researchers in automation research right now? So where's the niche?
So one thing that, I mean, this might be like very specific, but something that I'm very passionate about is like introducing these new technologies, what's robotics and AI, and what's possible to schools, students at a younger age as possible, like in primary school. Start from there, and when they see what's possible, we don't actually have to tell them what to do. They will come up with the creative solutions, because right. I think all you need to do is like show them the way, and then they'll do what's needed.
Good. You mentioned primary school. The final question for which we have had time is from Basu, who asked, first of all, thanks you for your insightful presentation, and then asked, does CSIRO have a program to train high school children about robotics?
We don't necessarily have a structured program as such, but in our lab and many other labs in CSIRO, we regularly have school groups coming through. We also, CSIRO does have this really cool program called Scientists in Schools, and I think now it's renamed as STEM Professionals in Schools. And it's not just limited to CSIRO researchers, but it's a matchmaking process between high school or even primary school STEM teachers. And doesn't even have to be CSIRO researchers, could be from universities or even industry. So it's a matchmaking process where you are identified as a STEM professional in school, and then you get to create your own partnership with school. So I myself am part of this program, and that gives you an opportunity to either go and visit schools, give talks, give presentations, demos, or even bring school groups into our labs and then show. So I would highly recommend any academics, researchers, industry experts who are in the audience to look it up if you search up STEM professionals in schools. So it's a CSIRO, it's a program coordinated by CSIRO, but not limited to people in CSIRO. But other than that, we offer ad hoc work experience for high school students in our lab. We've had a few students coming in, but we don't have a structured program for that based on requests and then availability. We support that.
Okay, great. I guess the suggestion is for people to look up this CSIRO website and find the material that's of interest. We're 1 minute over our allocated time. I think it's time to draw to a close. Thank you very much, everyone. Thank you to Navinda, obviously, for a very engaging and interesting talk, and for bearing with us and answering many questions. And thank you also to the audience, a very active and engaged audience, for all your questions and for attending. Hopefully you will have time to join us again in a fortnight's time. You've seen the slide there. Professor Hugh Bradlow will talk about the promise of digitalization and automation. Thank you very much again, and hopefully see you again in the near future. Bye.
Thank you.